Hi everyone, this is Mrs. GA, and today we're going to talk about symmetry. So by definition, a figure has symmetry if rigid motion exists that maps a figure onto itself. So there are different types of symmetry, and we're going to talk about two different types of symmetry here. So the first one says a figure has a line of symmetry if a reflection, which remember is a type of rigid motion, if a reflection maps the figure onto itself. So in example 1, we're going to try to draw as many lines of symmetry as possible for each figure. And if there are no lines of symmetry that exist, then we will write no line of symmetry below the figure. So remember, for a reflection, it's as if we folded the paper on your line of symmetry, your figures would match. So if you look at this first triangle, I can see that my line of symmetry would be right down the middle with a vertical line like this. So imagine you folded your paper on this line. I can see that this would fold over to here, this would fold over to here, so on and so forth, and the figure would match. For my arrow, I can see that my line of symmetry would be horizontal down the middle. And again, if you folded your paper on this line, this would match with this point, this would match with this point, so on and so forth. For my third figure, this one actually has two lines of symmetry. So we can do a vertical line of symmetry down the middle, or a horizontal line of symmetry across the middle. A common mistake I see is that some people try to draw a line of symmetry going diagonally like this or like this, but if you folded your paper on those lines, it wouldn't quite work. So these are the only two lines of symmetry. Now if you look at this S, you could try a few different lines of symmetry, but you'll notice that nothing will reflect the image appropriately. So this one we would say no line of symmetry. And then for the last one, this one's a little bit tricky. So I want to see if I can find a way to make this point match to this point. So again, I'm trying to match this corner to this corner. I'm going to match this corner here. I'd like to match the midpoint to the midpoint. So you can see if you cut that in half, our line of symmetry is diagonal at a 45-degree angle through the corner of your L. Okay, so now let's look at a different type of symmetry. This is called rotational symmetry. So a figure has rotational symmetry if a rotation maps the figure onto itself. So the angle of rotational symmetry, which is always going to be some angle between 0 degrees and 180 degrees, which is a half circle, is the smallest angle of rotation that maps a figure onto itself. And so we can always find this angle of rotation by taking 360, which is a full circle, and splitting it up into a fractional part. So here's what we mean by rotational symmetry. Take this star. Imagine that we had like a pin or something right in the center of your figure that held the center down, but you could rotate the figure going clockwise or counterclockwise. So we want to find that angle of rotational symmetry by seeing the smallest angle that would make your figure repeat itself. So I can see that since my 5 points of my star are divided up evenly, and I can see that like this. So I have 1, 2, 3, 4, 5. I have 5 even segments. Essentially, if I took maybe this point and I rotated it this amount, then I would end up with the same exact figure. It would look exactly the same as if I started. So how do we find that amount? Well, like we said, we're going to start with a full circle, which is 360 degrees. And since there's 5 equal segments in my star, we'll divide it by 5. So our angle of rotational symmetry is 72 degrees. And then if you rotated your star another 72 degrees, you would have the same figure. And another 72 degrees, you would have the same figure. So you could keep adding 72 degrees until you end up where you started. Okay, let's look at this next one. We have an equilateral triangle. So again, imagine you have a pin right in the center of your figure. Here you can see that since it's equilateral, all the sides are the same and all of the angles are the same, so equiangular. We could actually split up this triangle into 3 congruent segments. So again, I can start at one corner and can say, okay, if I rotated it this amount, my figure would look exactly the same as it does now. So again, let's start with our full rotation, which would be 360 degrees. And since there's 3 equal segments, we split it up into 3 parts. And we get 120 degrees. So that's our angle of rotational symmetry. All right, let's try a few more examples together. So in this next shape, I can see that I have congruent angles and congruent sides that are opposite each other. So for me to rotate this figure so it ends up looking exactly the same, if I start at the top right, I would have to rotate it all the way around to here to make it map upon itself. So again, if you have your center right here, I can see that this is a straight line right through the middle, or a half circle. So if you do 360 degrees and you cut it in half, our angle of rotational symmetry is 180 degrees. Okay, let's look at this next figure. So here we have a pentagon. It has 5 sides. All of the sides and angles are congruent, which means I can split it up into 5 equal segments, like this, and that means to find the angle of rotational symmetry, I can rotate it this amount, which again is 360 degrees, split up into 5 parts, which again is 72 degrees. So same as the star that we did previously. Okay, if I look down at this figure has a really irregular shape. First of all, it would be hard to even find the exact middle of this. And I can see that if I wanted to rotate this image and make it look exactly the same, I would actually have to rotate it all the way around into a full circle. And there's no other point in my rotation where my figure would look the same. So by definition, the angle of rotational symmetry needs to be between 0 and 180 degrees. And this full rotation is bigger than that. So we say that this one has no rotational symmetry. So essentially, if it takes a full circle rotation to make your figure look the same, it does not have rotational symmetry. Okay, and this last example, we have a vertical double arrow. So I can see that if my center were right here, I would essentially have to rotate it so the top of my arrow reached all the way down the bottom, which again is a half circle rotation. So I can take my full circle, split it in half, and I get a 180 degree angle of rotational symmetry. Okay, that is all for today's lesson. Thank you so much for watching.